Hello, this is Mr. Waterman. This is Geometry Lesson 12.1, Solids Geometry. We're going to learn definitions of some three-dimensional figures, which we're going to call solids. So a polyhedron is a solid that is bounded by polygons. Right, so let's take a look. We've got a few names, a few definitions that we have to learn. So first of all, the flat sides of a polyhedron are called faces. Okay, so the faces are always planes. So on this particular polyhedron, we've got 6 different faces, if you count them up. Many of them, 4 of them, are rectangles, and then we have 2 that are trapezoids. Okay, so in addition, we have edges. Edges are where 2 or more of the faces intersect. So this would be an edge. Right? So the edges are lines, and if you count those up on this polyhedron, you'll find out there's actually 12 of those. And then the last is a vertex. So that's a point where on this polygon 3 faces are intersecting. Okay? So we also call them the corners, and there are 8 of those. Plural for vertex is vertices. Okay, we have a formula that relates faces, vertices, and edges. So on any polyhedron, the number of faces plus vertices equals edges plus 2. Okay, so we can try this out for our example up here. We had 6 faces. We had 8 vertices, and that's going to equal the number of edges, which we counted up to be 12, plus 2. So both sides of that equal 14. And that's called Eulers or Eulers formula, depending on how you pronounce that funny name. Okay, we have a few types of solids. So the 2 we're going to work with in this class are prisms. So prisms are bounded, they kind of have flat tops. I always say they make good tables or chairs. All right, we typically call it a box. This particular one's a rectangular prism. Our very first example up here was also a prism, and we would have called that a trapezoidal prism. So it's named by the faces that are not rectangles. And if they're all rectangles, then we call it a rectangular prism. A pyramid has a vertex at the top. And I always say these don't make good chairs or tables because it has a pointy top. Right? So we name these based on whatever the base is that it's sitting on. So we use the base name as its first name. So this would be a rectangular pyramid. We can have pyramids that have any polygon for its base, from triangles, rectangles, all the way up. Octagons, pentagons, hexagons, all that stuff can be a base for a pyramid. And then this group of green solids over here, these are all not polyhedra because it's not bounded by polygons. So cylinders, cones, and spheres. We'll be working with these in our solids geometry, but you have to know that they're not polyhedrons. Okay, it's time for question 1. So, using our formula, faces plus vertices equals edges plus 2, if a polyhedron has 4 faces and 4 vertices, how many edges does it have? So go ahead and calculate that using F plus V, faces plus vertices equals E, edges, plus 2. Alright, rolling on. Let's try some examples. Tell whether a solid's a polyhedron. If it is, name it, find the number of faces, vertices, and edges. So I'm going to have you go ahead and watch part B.